Good day to you, sir. My name is Adam Shaharuddin, and today my group and I will be presenting our assignment 2 to you. So after a thorough analysis on the company's business model and the data that we've gathered from our previous assignment, we have decided and agreed on 3 modules that shows that I can use to expedite the company's processes. Starting off with product catalog, we have decided to use Amazon S3 for these reasons. Number 1, product images. The images will be stored in S3 buckets where each can have one or multiple images associated with it. It provides high durability and availability, ensuring that product images are accessible and reliably served to customers. Next is media assets. S3 can organize the media and make them available for viewing or downloading as needed. And lastly would be scalable storage. S3 offers virtually unlimited storage capacity, allowing for large accommodation of products and media files. Next, we have order management, and for this we agreed on AWS Lambda, and here's why. First of all, order validation. It triggers to perform validation checks such as verifying product availability, customer information, and ensuring payment authenticity. Next would be inventory updates. Function can update inventory records in the RTS database based on order processing events. Lastly, it also has error handling, which functions can handle error and initiate retries or error notifications when processing orders. Lastly, customer relationship, which also uses AWS Lambda. The reasons being are these customer notifications can be triggered by events such as order updates or product releases. Second would be data validation. Validate and enrich incoming CRM data, customer relationship management data from different sources. And lastly would be personalized recommendations. It is used to calculate personalized product recommendations based on customer data and browsing behavior. Now, all of this will not function without a place to store all of it. So we recommend AWS RDS for all the management options. And we chose it because it has, for these 3 main points, which is structured data storage, efficient querying, and automated management. Now, structured data storage, it stores data in a structured manner using a relational database. It ensures consistency and integrity. For efficient querying, it supports SQL for a powerful and standardized way to retrieve specific information based on criteria. And lastly, automated management. RDS is a managed service, which means that AWS handles the routine database management tasks such as backup, software patching, and maintenance. Now, that's all for me. I will pass it to my next teammate.
Thank you, Adam. My name is Wanash Hakim, and I'll present on the implementation of Amazon S3 and AWS Lambda as mentioned by Adam earlier. I'll begin with Amazon S3. First of all, we will go ahead and create a new bucket in the S3 dashboard. Here we'll give the bucket a name. In this case, we'll name it Shazada S3. We will choose to disable access controllers, and this will keep access to the bucket to the parameters specified within the policies. This will serve as an extra layer of security and protection and is recommended by the AWS platform itself. Then we will choose to block all of the access to the bucket. Similar to disabling the ACLs earlier, this is an additional layer of security to ensure only the specified personnel are able to access the bucket. In this case specifically, we are preventing the public from being able to access the bucket and view its contents, which also helps increase privacy for the data stored in our S3 bucket. We will also enable bucket versioning. There are several reasons for this. The first is data protection. Versioning will allow the restoration of previous data in the event of accidental deletion or data being overwritten. In terms of auditing, versioning can also be helpful by tracking and monitoring changes to data, which allows the owner to view who made the aforementioned changes and when, which is extremely useful for troubleshooting problems or investigating security incidents. Finally, versioning can also help with recoverability. Versioning essentially helps to create a backup and recover the contents of the bucket should any accidental deletions occur. This is possible as versioning creates a history of all the changes that has been made to the bucket. We will then encrypt our data using the SSE-S3 server-side encryption, which is yet another security feature of ours. Encryption is important as this will help conceal any data and files we have should someone manage to hack into the bucket. We will also enable bucket keys in order to reduce the aforementioned encryption costs. At this stage, the bucket is completed. We'll now move on to creating folders within the bucket. Inside the bucket we just created, we will now create new folders. For the sake of the example of the presentation and the report, we will focus on the creation and usage of the product images folder specifically within the bucket. We will give the folder the aforementioned name of product images, and once again use the SSE-S3 server-side encryption as a form of security. Repeat this step for all of the folders. Now we will begin uploading our desired files into their respective folders. Once again, using the product images folder as the prime example here, we will now open it and select upload. We will then drag our image or select add files and select our desired files, which in this case is a poster of a vacuum for sale. After uploading the image, we will wait for the status to change from pending to succeeded, which means successful upload. This concludes the step-by-step process for creating Amazon S3 buckets. And now we'll move on to the AWS Lambda. First, before we create the Lambda function, we must first create a policy for it within the AWS IAM. This is because the function needs to have permissions to access the resources that you'll be using. For the sake of presentation, we'll now focus on the creation of the AWS Lambda function, which will duplicate any files uploaded in the main bucket to a backup bucket as an additional source of backup in case anything goes wrong. First, as mentioned, we will now create a policy for it within the IAM. Here we will select if we wish to create a policy for S3 specifically. Then we will give it its allowed permissions, which in this case will be our read and write actions. We will then give this policy a name and description, which in this case will be S3 Lambda copy uploaded items. We will then select the JSON and input our JSON code to tell the policy which is the source bucket and which one is the destination bucket. We tell this through the use of the respective bucket ARNs, which we copied. And this now completes the policy. After creating the policy, we'll now create an IAM role for the policy. This IAM role will be the AWS service and use a Lambda use case since we of course want to use it for Lambda functions. We will then assign this role the policy we just made earlier. This completes the role. Now that we have created a policy and assigned it to a role, we can begin the actual AWS Lambda function. We will give this function a name and give it the role we made earlier, which contains the needed policy. We will then hit our source code and code within it the code which will run our desired purpose, which once again in this specific example is to duplicate any files uploaded in the main bucket into our backup bucket. After creating the AWS Lambda function, we should now test it out and see if it's functioning as intended. We will now hit to the main bucket and upload a new file. To see if it has worked as intended, the same file should also appear in the backup bucket, which we can see it has, meaning the Lambda function works. As you can see up here, this is the backup bucket. This concludes my part of the presentation, and I'll pass the floor to my groupmate Arif. Thank you.
A very good evening, sir. My name is Arif, and I'll be guiding you through the process of how I created the RDS. So I started off with creating a VPC, and I named it Sandbox. It has two availability zones, two public subnets and two private subnets. The NIC gateways are set to 1AZ, and the VPC endpoints are selected to S3 gateway because, as you are aware, my groupmate Hakim uses the S3 services. The DNS options are both enabled, therefore my VPC is created. The next step is to create the security groups for my VPC. The security group name is called Sandbox Security Group, and the description is enable HTTP access. The secure HTTP feature is one of the security measures taken by me. It provides me with a secure and encrypted method to access the router via web browser using secure socket layer and transport layer security. This prevents HTTP sessions from being intercepted or attacked. The VPC is chosen, this one here. The Sandbox VPC that I created earlier. The inbound rules type is HTTP, source is anywhere IPv4, and the description is to permit web requests. Therefore, my security group is created. And next up is the EC2 instance. After creating a VPC and a security group for it, I created a EC2 instance and I named it Sandbox Server. The Amazon Mission Image AMI of my choice is Amazon Linux 2023. The instance type that I choose is T2.micro. This is because T2 Micro are one of the low-cost instances. And the key pair login is a new Sandbox key pair that we made. It will allow me to connect to the instance via SSH after it has launched. The network settings is as shown, VPC, Sandbox VPC that I created earlier. Subnet is one of the public subnets of ours. Firewall security group is the existing security group that I made earlier for my VPC as well. This script will run with root user's permission on the guest OS of the instance. It will run automatically when the instance launches for the first time. The script installs a web browser, a database, and PHP libraries, and then it downloads and installs a PHP web application on the web server. My last services that I'll be using is the RDS. Creating the database is using the standard creation. The engine of my choice is MySQL. Templates I use is developer test, and the availability and durability is multi-AZ database instance. It is called Sandbox database, and the master username is group5 username, and the master password is as shown below. It's a secret. And then instance configuration. DB instance class is burstable classes, selected to DB database T3 Micro. T3 instances are the low-cost burstable, same as the T2 instances that I use for my EC2. It's low-cost as well, but it's burstable, general-purpose instance type that provide a baseline level of CPU performance and the ability to burst CPU usage at any time for as long as required. And the storage type that I chose is general-purpose SSD GP2. Storage auto-scaling, as you can see, is enabled. It can continuously monitor actual storage consumption and scales capacity up automatically when actual utilization approaches provisioned storage capacity. Compute resource, virtual cloud VPC selected is the VPC I created earlier, using the subnet that I created earlier. Public access nodes restricted. VPC security group is the existing database security group, and the database authentication we use is by password authentication. And we enable the encryption tag, and below there is our encryption key. Navigate back to the EC2 instance page, and then click on the Sandbox server. In the details, you can find public IPv4 address, and you can copy it and paste it in a new tab. It will launch this. Once 100% has reached, navigate to RDS and enter the details as follows. Okay, so first of all, I'll show you how we remove a user. As you can see, we have 1, 2, 3. We will be removing user 3. And now we only have 2 users. Next up, we will be editing the user. We have user 1 and 2. We will be editing user 2 and change it to user 4. As you can see right now, we have user 1 and user 4. Lastly is adding users. We have user 1 and 4 only at the moment. Then we add user 5. So you can see once updated, we have 3 users. And that is all from me. Thank you.